The first question I got wrong was question 7 on the multiple choice. The way I went about answering this question was that I linearized the data by squaring time, plotted the values on my calculator, and used linear regression on my calculator to find an equation for the new data. Through this method, my calculator gave me the following equation for the linearized data: y equals 26.4x plus negative 0.02. The mistake I made while doing this problem was that I assumed that this equation in the context of this problem would be velocity equals 26.4 t plus negative 0.02. As a result, when taking the derivative, I would mistakenly find that the acceleration is 26.4 meters per second squared. So this is wrong. What I should have done instead was realize that the variables being graphed when I was linearizing the data are x and t squared. As a result, I would know to rewrite the equation from my calculator as x equals 26.4 t squared plus negative 0.2. I could then find the acceleration by finding the second derivative. I would then find that the acceleration is 52.8 meters per second squared, which is the correct answer choice. The next question I got wrong was question 8 on the multiple choice. The question asks what the new speed of an object released from the top of a building would be if the distance d, which is the distance the object has fallen from the point of release, were to be doubled. The way I went about answering this question was by first solving for velocity at distance d by using equation 5. I then solved for velocity again. This time distance was 2d, and I named this velocity as v2. I then divided v2 by v to find the ratio of the velocities to see how many times greater v2 was to v. When I was evaluating this ratio on the test, the mistake I made was that I forgot about the square root and mistakenly found that v2 was 2 times greater than v. What I should have done instead was recognize the square root and reevaluate the ratio as 2 over root 2. Two over root 2 simplifies to 1.41. Therefore, the answer is 1.41v. The next question I got wrong was question 18, which asks what would happen if a coin and a feather were dropped from the same height in a tube without air. The answer I chose was that the coin would drop to the bottom of the tube first because it has more mass, therefore the force of gravity would be greater, thus pulling the coin down faster. This reasoning is wrong because according to F equals ma, which can be arranged to F over m equals a, even if the mass and force of gravity increase, they will still maintain the same ratio, which is the acceleration. As a result, both the feather and coin would have the same acceleration regardless of their mass or force of gravity, and will therefore fall to the bottom of the tube at the same time. The next question I got wrong is question 19, which asks for the maximum positive velocity given the following position function. The way I went about doing this question was to differentiate the position function and then find the axis of symmetry, which is the x-coordinate for the maximum of the velocity function. The reason I got this question wrong is because when I was differentiating the position function, I thought that the derivative of 4t was t instead of 4. When the position function is differentiated correctly, we find that the velocity function is 4 minus 18t. When we find the axis of symmetry by using the formula negative b over 2a, which is 0, and plug the coordinate into the velocity function, we find that the maximum velocity is 4 meters per second. We know that this is the maximum positive velocity because since the a term in the velocity function is negative, the graph opens down. Therefore, the answer is 4 meters per second. The next question that I got wrong was question 2. I did not know how to do this question, so I just guessed that dB was half of dA. The correct way to do this problem is to use equation 4. The first thing we do is we can set dB equal to 1/2 g 2t squared. This simplifies to 1/2 g 4t squared. Next, we can set dA equal to 1/2 gt squared. Next, we can divide dB by dA to find the ratio by which dB and dA are related. We get that the ratio is 4 since 1/2 g and t squared all cancel out. This means that dB is 4 times greater than or 1/4 the size of dA.